So yeah, be precise and accurate, and you've also got to work quite quickly. But again, don't expect to get all 20. But I mean, we're looking at the first question now, so we may as well do it. Two circles on the same radius, this circle and this circle. So we know the equation of these circles then, right? We swap these signs over to make this one and then this one. They have the same radius, so we can call them both R. Of course, they both equal R squared, so I can just set them equal to each other. And what happens nicely here is that all the x squareds and all the y squareds all cancel, which is really nice. Gives you an equation x and y, and of course an equation in x and y just represents a line, which is the line that we're looking for here. So we just need to do some simplifying and some cancelling, and we'll end up putting it in the form they want it, which is this one here, down there, and we'll get our answer. So yeah, quite a nice little warm-up there. Question number 2, so a curve has that equation and turning points here and here, so let's first find the turning points of this curve. The best way to probably do that is to differentiate and set it to 0, because turning points when divided by the x equals 0. Solve for that, we get our turning points at plus or minus root 2. Of course, if beta is bigger than alpha, then that means beta is plus root 2 and alpha is minus root 2, so this is the integral we're doing. Then we just need to follow integration stuff. I'm sure you guys know how to integrate. Substitute the two values that you have in here. Just be very careful when you're squaring and so on, that you end up with positive values and such. Again, be careful expanding out this bracket. If you don't expand this bracket out properly, you'll end up with one of the wrong answers. Negative and negative make positives, of course. So these things cancel, these things add up together to create 6 root 2, and that will be our answer. Question number 3. So we've got an arithmetic progression, which is when we add the same amount each time to get to the next term, and a geometric, which is when we multiply by some amount each time. So if they both start at term a half, the arithmetic goes a half, half plus some number r, half plus 2r, and so on. Whereas the geometric one goes half times s, half times s squared, and so on. So you're timesing by s each time, adding r each time. Now, the sum of the second term, so these two terms added together, is this, is half, and the sum of the third terms added together is an eighth. Now, let's just deal with this quickly. Okay, so this is Tamura 2021, paper number 2, 20 questions, 75 minutes. You've got to work pretty quickly. Let's get straight into it. First question is just simple integration. Change these powers to be fractional or negative, so you can actually integrate. I'm not going to go over this in elaborate detail, because if you're taking this very seriously, you should know how to integrate the units, and you should factors in, and you should get the answer. Question number 2, which is more interesting, you've got two coordinates here, 0, 2, and 0. You're told that there's opposite sides of a square, so that's the opposite of the square. The square has to be diagonally, so look across like this. More importantly, if I can link those two points together, say the square's diagonally must, this is one of the diagonals of the square, the other diagonal must be perpendicular to that and go through that same midpoint. So what I need to do is say, well, the gradient of this line here is, the midpoint of it is 2, 1, I guess, 2 across 1 up, it's 2, 4 across. The gradient is minus 2 across, which is minus half. So the gradient is perpendicular when it's 2. So the equation of this line, which goes through B and D, would be around here. by equals 2x plus c, where it goes through 2 plus c. I mean, this number 3, sorry. Students rest random class, each student is likely to be completely which the target necessary to exactly the academic class. It's not necessary. If you double up this fraction to say 8 over 30, then you've got 22 non-wearing class members. So definitely this number of students in class is quite great. Now this is slightly more. Slightly more, but I guess like when you simplify fractions, this is for reasons. When you go up or down fractions, simplifying or unsimplifying, you have to multiply between 1 by the simplifier. So like all of these are equivalent fractions for the multiplied by 2 over 2 or 10 over 10. But you can't get rid of this. So the total number, which is on the bottom for students in the class, that's always number spike where you can't remove it. There's nothing on the top. We did 3 times 3, but you still got it. So yeah, this is definitely necessary. Student, and then there's third one, that's completely unnecessary. So again, it's complete. Double point. So only a second one is necessary. And sure, question number 4. This is quite interesting. A is a factor of BC, then A is a factor of B. That's B. A is X, so let's just go for this.
I was much bigger face than you was about.
A is definitely a factor of G. this is where we learn something about Tamura papers, which Tamura considers to be, they consider both and. So I thought this was actually a counterexample. It's not a counterexample, because Tamura considers this word to mean and. So this isn't a counterexample. This is, because A is a factor of 16, which is 4 times 4. But 8 is not a factor of 4. So this is a counterexample of neither of them. And this is not because 6 is a factor of 12. And this is a factor of 81. So these two are not counterexample, but this one is. Just remember, you actually see it twice in the fake where it doesn't really mean in a computer science sense, it just means it. Well, that's why we look at papers and think about these things and their expectations. It actually does say that you read the logic and proof notes very carefully. Question number 5. So where is this one wrong? Well, okay, so you move the sign spread over and then you just go to the addition. Sounds like a big question. Should have done plus minus. Question number 6. So f of x equals 0 for exactly 3 values. So essentially it's saying f of x has 3 roots. This is saying f dash of x equals 0, 2 values means that's 2 stationary points. So we're looking at a graph with 3 roots, 2 stationary points. The first graph that comes to mind is
That's going to attract the attention. Keep the hostiles
what it's saying is which of these through is P necessarily huge.
It's like a symphony of bodily harm. What's wrong? The juice a little too much for you?
So, Tuesday points. So clearly, having 3 points is not necessary. Tuesday points. It's clearly not necessary. They rings, but not Tuesday rings.
Almost good.
So it's clearly not sufficient. You're saying the right thing. Sufficient to say that.
I'm still standing, you scum-fucking bastard.
Yeah, it's quite late. And number 7, so we've got a circle here, so radius 2. So radius 2, interestingly, means that it's the x-axis there. And we've got a square, that's 610, it's 1 so that's the square here, slight angle 2, big one.
Two in the chest, 1 on the head. Spoiler, the head's all you need.
Now, to bisect the area of the circle, you want to go through the center. Any line in any direction, as long as it goes through the center of bisect the view. So how do we get a line to go through this center, and then also bisect this one? Well, it needs to look a bit like this. This point here needs to go through this square. To bisect this area, we're making 2 details. Rotation needs to go through this point here, the center of the square. This thing is place up this thing is 2. We actually need to fix the axis. Straight on the axis. What we can see here, we've actually got 2 sequences. This one is so this thing is x. This thing is 2x. That's this one. It's just 1 as big as this one. Of course, this is the weight line across. This x is 2x. So 3x. X equals 3. Pretty nice question. Question number 8. So consider the following statement about a polynomial. There exists a number c between square numbers a and b, such that the derivative of c is 0. And again, a necessary and sufficient thing. So again, we're thinking of examples. Let's think of you an idea what this is talking about. You have 3 points a, b, and c. And the c bit has the derivative of the function b0.
Nothing like a little upgrade to make man feel young again.
This example right here eliminates confidence because the condition P A is
I know you're weak, but do the best you can.
function is B is that true? Well, in this drawing that I've done here, P of A is 0 because it's on the x-axis, but P of B is some positive number.
One more
So
item.
P of A does not equal P of B. We do understand really it's not necessary. There's an example that just disproves that. Is it sufficient though for P of A to equal P of B? So let's draw a function where P of A does equal. Does that happen to be a number in between A and B such that there's a turning point? Well, it does if there's a polynomial. You can think of funky graphs that kind of concentrate between the two and to the x-axis, but if you've got two functions that are in place together, there's a polynomial which is a smooth continuous function. It moves between the two. So it is sufficient, but it's not necessary. That was the first. Question number 9. So it's not to this, where P doesn't equal 0, it's the cubic. As long as P doesn't equal 0, it's the cubic. There was a real T originally. 0 explains the same point. Is any function of the same point? It means that the two numbers are most likely less than 0. One has to be positive, one has to be negative. So this is saying that there's a function in some areas below the x-axis and some areas above it. Some areas with functions negative, some areas with and it's saying which of these conditions alone is sufficient to conclude that it has a root, essentially. Now, let's start with the first one. Cubics. Cubics have at least one root. So cubics definitely have one root. It's just a thing that you learn in A-level words. Then we move on to statement 2. Thinking about functions that have a stationary point, do they necessarily have a root? Is it sufficient to say that it's a root? Or here's a function that has a stationary point but no root. So it's not sufficient to say, oh, if I have a function that does this, then I have a root. It's not sufficient. So of course that'll be yes for option 2. Now we're down to the other side of statement number 3. Statement number 3 says that some area of the x-axis is below something is held to be positive. That's the case. Plus the x-axis big F.
Hard to watch like that.
If you're in year 13 and you've got
some really meeting,
goes, if you haven't filled out your unit, blah 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 blah. If you have, you stop listening regularly. If n is prime means for any n that isn't prime, you stop listening. So the n's that are prime, this, the parameters, is not prime. It's possible of 3.
I took one for the team.
Okay, so this number here, that's possible 3. This number here is possible for 3 and 5. That's okay. Remember, that's okay. This number here is not possible of 3 or 5. So Claudius counter is your student has the following problem. Show that if this, then this. Okay, so let's just run through this. So, okay, there, square again, that's fine, square correctly, using the square on this bit, it's taking the using up to my x square, so square is definitely positive for real numbers, so we don't just swap the sign, so that's fine, and then they made this shoot, it's given to them, they were so all those lines are correct.
Looks like we're going to fight another game.
If this, then this, you can't say this is true, because that's what you're trying to show. They just use it. So here is correct. Not entirely the proof. Just this option.
Fuck, you ain't peeping.
It's incorrect.
I packed in the open casket while we were
Why wasn't it? It's here. Again, it's not that because just writing in reversible. Because again, the first line, if you imagine this reversible, the first line, if you use this line, you can't just write reversible. They've just done the entire line. I think you understand. They proved basically thing and said, show if there exist numbers x and y that do this, then this, they've shown that. So they've written down
Tastes like formaldehyde.
they've the statements, which is this one. And this big energy now this feels true, and sometimes it's not things that feel true. So here's the function. It's always just rely on
Guarding the underworld or some shit.
because this in the positive section, you just get the negative, which will get big enough where it's very G. It will be a bigger negative, which is stimulus. So this is just, there's very complicated proofs of that, but you're in the middle of a tutorial paper. Don't do complicated proofs. Just go with gut feelings. Expressions. You've got those questions to do. Next one. If f of g is bigger than, so the same thing here, then the derivative of f is bigger than the derivative of g. So, again, counterexamples here. Examples and counterexamples. Let's come up with a bunch of things. So it's always bigger, except the gradient, which is knowing, the gradient of f here is negative, whereas the gradient of g is always positive. So this is the trick. Let it be the same. So this is contrary. That's the next one. To do with the gradient of g, then f is always bigger than g. This here, like all this here. It's always bigger than the gradient of g, because g is just a negative gradient and f is a positive one. And we can see here g is bigger than f. This is lower, so this is one of our string gradient. Let's write this. So that's what basically some things to that size. This. It's very easy to work just this being the green bit. Like spread to both sides we get true. The next spread to both sides we get this, which is a quadratic with points of 1. So like this we can find these 2 points if we want to. It can be a great number as well. This is going too far. By the way, yes, we know you could find these second points if you want to do. I'm not sure whether it's necessary, but I did anyway. Is x always between plus and 2? Well, no. Let's try over here, you have the in this region. Now, I think this is tricking people who assume that this is the region. But it's not all of this is, because you're less than both of them. This is complicated, so let's look at this one. Y is less than 5, of course not true. Up here we have the coordinate maybe 10, 20 or 10, 15 or something. So y can definitely be bigger than 5 because r encompasses all of this below this line going up there. Or this one here, again, just try and find a counterexample. There's probably more mathsy, intelligent ways of doing it, but I just picked this point down here. I noticed if I did that, x is 0, y is minus 10. I get this minus 10 times y is this, which is definitely. And so this point disobeys this. And so it's none of them are true for every single point. Good. Counterexamples. Don't know how many times I've done that. Anyway, so there's frames. Immediately has to take these away to get this. And this one grows. Now, I've got 2 numbers here multiplying to make 1. This number. Is always positive. Which means that this has to be positive. For the 2 things to multiply to equal 1. That has to be positive, which means b has to be bigger than 1. So that's one condition. Now let's consider what happens if I eliminate the accidents that then I can take it, you get this, which is you get the other car, and then they goes to use this doesn't really seem like I've got anywhere. They took me a
What?
Oh, to figure out what to do there. Okay, imagine this was y squared. Let's you would square root both sides. Y cubed, you would cube both sides. Y is the p minus 1. You p minus 1 root for both sides. But that's the same as writing to the power of 1 over p minus 1. It's like here's a fraction. So as long as the big root is area. That's okay because this condition here needs to be bigger than 1. So the final condition this all makes sense when you go 1 here. Let's make it e is 1, we get 0 here, and then twice e is 1, which I think looks like gives you an inkling that e is 1. You can no longer choose y to get it. Question number 15, we're getting through it quite nicely now. This question I went to a very dark alley for a while until I realised there was a much easier way of doing it. Here's a circle. Not into the so it makes which essentially speaks for me. And this is equal to 0 meters, which is what I've done. I want this to have 1 solution. I want this to have 1 solution. It needs to have 1. So I think this is 1 and 0. So, okay, I agree with you on this solution. It's necessary in this solution. I think this. The reason it's necessary in this solution is because the discriminant check is a necessary and sufficient thing. So it leads from that. Like, there's no instances in which this equals 0. Itself is necessary and sufficient checks. 16. Love drawings. These mod drawings, this question is great. So this graph is whenever you ask
Be advised, exfil windows closed.